Then we'll start up again next semester. There's still a lot of spaces open, so you can give me ideas about who you'd like to see next semester. We have something left over for outside speakers, if you, especially if you know of anybody coming into town anyway, or who you're enticed to come into town for one reason or another to do research. Also, any faculty that you know of around here that you haven't heard from recently, or hit or whatever, then please send me your ideas about who should speak. The slots fill up fairly quickly, so don't wait till next semester. Might not be any slots available. So the speaker for today is me. I guess I'm introducing myself. I better look and see what I want to say. And I'm going to be talking about some of the work I've been doing with handheld computers, and I brought a lot to play with, some of which I'll be using and some of which are just here for show because I can't actually play with them all. I'll probably start with this one. And this is a project that actually started off as an undergraduate idea. I had a student who came and wanted to work on Palm Pilots, and we started a little project. It grew into a pretty significant idea. I got a lot of funding for it, and now I have 4 or 5 different people working on all different aspects of this. So sometimes little projects grow into really interesting work. I call it Pebbles. And the basic idea is that people have, more and more, have some kind of portable computer. How many people have a portable computer with them? PDAs or something. About a third. And some of them are the Palm Pilot style. Windows CE. How many people have Palm? Windows CE? Is that anything else? Anybody have a Sharp or something? What do you have? Okay, anybody have a laptop with them? Okay, so this is part of the point, is that people are bringing these little devices to meetings, they carry them around with them, sometimes they use them to take notes on, and the issue is, how can we make use of the fact that people have these devices already? Okay, so we are leveraging off the fact that people have these devices, and most of the time they're sitting in their pocket. Maybe we can get people to take them out and do something useful with them. Another point is that the price is coming down dramatically. There are expectations that the price of these things will be around $100, maybe in this range of Game Boys, which are about $80. And then, certainly the number of people who have them will certainly explode. Also, they're going to be newer and lighter and more convenient form factors. The pad computers are going to get this is over $1,000, but they're going to be $500 versions of this available pretty soon, and then, a whole new class of people will be interested in getting them. And another important point, most of the time people think of these kind of computers as a replacement for a PC. That they're going to use these when they don't have their PC around, when they come to a meeting, when they're walking around campus. But if they have a laptop, then they'll just forget about their PDA. Our research focus, which is different than most other people's, is how you can use all these devices together. How you can leverage off the fact that people are going to have multiple devices at the same time. And also that there are going to be multiple devices of the same kind in the same room. So that there are a bunch of people who have PDAs in here. Maybe they could talk to each other and do something useful. And then another important point is that you see a tangle of wires here. If you come into my office, I have even a worse mess of wires there. But this kind of wireless technology that you can now get for fairly large computers is expected to be available in palm-sized computers next year. Of course, we heard that last year, but I'm a little more optimistic. My student has seen a demo, so that must mean it's practical and will be available. Although they won't let us actually play with it yet. So when we have wireless communication in this form factor, these boards, how many people have a waveland board? like this. Nobody here? They're about $300. So the computer's $1,000 and the board's $300 more. Again, the price will go down significantly next year as they get to be even more, smaller form factors and more integrated chips that do this kind of work. So that with this coming wireless, ubiquitous communication, then the connecting of all of these devices together is going to get to be more and more common, more easy to do. And so the communication between multiple devices is going to change from being an occasional event that you do when you're hot sync to being the case that devices will be in close interactive communication. I really like this quote. Feel free to use it in your documentation, and if you want to attribute it, of course, I wrote it. So what we're trying to discuss, the main focus of the Pebbles project, what we're trying to do is look at how you can use multiple devices at the same time. How these kind of devices can be used as an augmentation to a regular PC, not as a replacement. If you're familiar with any of my research projects, you know they all have cute names that are built out of acronyms, and Pebbles, of course, is no different. It stands for PDAs for entry of both bytes and locations from external sources. Oh, that's not good. We worked very hard on that. So we're using the PDAs, handheld computers, as extensible input and output devices, connected to PCs, both for groups and for individuals. So a lot of the things we'll be showing you is designed to make groups more effective. Some of it is for a single person with their PDA and their PC together. And there are many other people studying the uses of handheld computers when they're not connected, for taking notes and other things. So we didn't want to reproduce that research. Our research style in my group is to create applications, to do user studies on those applications, actually create these tools that are robust enough that people can actually use. So most of the software that I'm going to show you is available for you to download and try out. And I invite you to, if some of it looks useful or interesting, then to try it out. Of course, we also have APIs. If things sound interesting and you want to program up something slightly different, then that's available as well. And of course, because we're in the HI Institute, we do a lot of both formal and informal user studies of the software to make sure that it does what we think it's going to do. So first, I'm going to talk about meetings and presentations like this, and also little meetings, so group activities. And it's only one person here is actually taking notes using a computer. Everybody else is still using paper or not taking notes at all. This is true in most meetings, even though probably how many people here own a laptop? Right? Almost everybody owns a laptop, but you never bring it to meetings. It's fairly rare. There are certain social reasons, technical reasons, and others why people don't bring their laptops with them. The clicking is annoying, it's socially unacceptable, and things like that. There's been a lot of research on how you can use a bunch of computers in a meeting, and most of those involve using special rooms that have all these computers installed, like the classrooms down the hall. And those are usually very awkward to use. It's hard to set up, and we don't want to. We want to see if we can use this kind of technology instead. And again, we're going to leverage off the fact that people already have their PDAs. Another thing I should mention in terms of wireless and having devices is in a lot of countries, everybody in the room will have a cell phone. That just reminded me of that. And cell phones actually are getting to have fairly sophisticated processing in them and fairly sophisticated displays. And so some of the things that we're showing could actually be done with cell phone technology to the extent that they become more programmable. And a lot of this, would then be even more ubiquitous. So we're mainly targeting local meetings where everybody's in the same room, and there's lots and lots of research out there about using technology to help people who are in remote rooms, net meeting and all sorts of things like that. So we're focusing on everybody in one room, and as you know, many conference rooms, including this one, meeting rooms, have a computer built into the room, projected on the wall, Okay, that's one computer, and then everybody has their PDAs. Did you want to ask something?
A sense of how many people were?
Well, 4 to 10, that kind of thing. Small meetings, but for lecture kind of material that we're, like this, then we can talk about hundreds of people. So we are looking at presentations which are very much uneven in some sense, in terms of you're not really supposed to be talking, not even calling you. So I can do that. If it was a small group meeting of 4 to 10 people, then it tends to be much more. Okay, moving on. No, that's not. Go ahead.
You have pointed out that nobody was taking notes. I assume this stuff is on the web.
Right. So there's a lot of interesting research we heard from Greg about last time about effective ways of taking notes and remembering things and that kind of stuff. So that's another talk, and it's already been given, so I don't have to talk about it. And in addition to these kind of formal meetings, 4 to 10 people, presentations like this, there are also informal meetings where my student comes into my office or we meet in the hall, and again we'll typically have our PDAs with them in our pockets or purses or on our belt or whatever. And then maybe this technology could enhance those kind of informal meetings as well as the more formal meetings where everybody is already set up. And then at the desktop, the newer kind of PDAs like this one or the Palm 5 or almost all the Windows CE devices are rechargeable. And that means that when you come into your office, you're supposed to put them in their cradle and charge them. Okay, so you walk in your office, you take your PDA, put it in the cradle, it's connected to your computer. Maybe that could be useful for something since it's sitting there. So this is another thing that we're going to be trying to explore. And there's been a lot of work on using two-handed input. Bill Buxton in Toronto, for example, is very much interested in how you can use two hands to do input. And but no one ever does, right? How many people have two mics connected to their computer? Of course, nobody here does, and people probably don't. Anybody have anything interesting connected to their as an input device besides the keyboard and the mouse? Okay. So there's been research that shows that using extra input devices can actually make you go more faster, and we have a study we did last summer that confirmed that. But nobody does. Maybe having a PDA connected to it could serve as this extra input device and actually make things go more effectively. Now, we want to use PDAs in an appropriate way. A lot of times you hear about people putting a web browser on a Palm or trying to use their desktop applications on a PC, PC applications on a handheld device. We think that's an inappropriate use of this technology. If you really wanted to browse the web, or if you really wanted to do some of these tasks, then you might as well use a laptop, especially in the situations where we're talking about where you have it in front of you anyway. So if we're talking about using multiple devices together, use the PC for what it's good for, use the handheld device for what it's good for. We want to take into account the limitations of these devices as well as their advantages. The other point is that the main focus is typically on the main PC screen. Okay, so that this is just an adjunct. It's your personal data space, maybe a place to scribble or something like that. But you're not supposed to be spending all your time down here looking in your hand. You're supposed to be looking at the speaker, looking at the main screen, whatever, participating in the discussion. How are we connecting? Well, we're using a lot of wires, serial cables. The advantage of that is they're cheap and easy. Everybody gets a connection like that with these devices. It comes, right out of the box with a cradle, and the serial cables are only a few dollars. Unless you want special purpose ones, it's about $10 per cable. So it's really easy to do. Everyone asks about infrared because all of these devices actually come with infrared built in. And we support infrared, but it's a really bad idea. And the reason is that infrared is very directional. And it's also short range. If you think about your remote control for your TV, you have to aim it, at the TV. And if you aim it a little bit askew, it doesn't pick up. The infrared in these devices has the additional problem that it only goes a couple of feet. Okay, so if I want to use this device under infrared, then I'd have to also find the infrared slot on my laptop and do like this every time I wanted to talk. And as you see that for writing or almost any kind of even pushing buttons, it's kind of awkward to use infrared because of that directionality. So we really need a radio technology. Obviously, this wireless LAN from Waveland is really good, although it's kind of big, so it doesn't plug into these little devices. There's something called personal area networks that are coming out next year. Bluetooth is one. There's another one called HomeRF, which is Microsoft's competitor to Bluetooth. There's some thought that these might actually merge, which would be good for the whole industry, because then there would be two competing standards. And as I was saying, that we saw this demonstrated on a Palm device, a handspring, which is a Palm clone, this last month. And so we're optimistic that that will be available in much smaller footprint. Another thing I'm always asked about is, what about the Palm 7? If you're familiar with that, anybody have a Palm 7? It's a Palm device with an antenna built in. And another thing that's related is CD/PD. We had a talk from some guys from AT&T last year, which was the same idea, which is you get a device like this with an antenna. And it uses a cell phone technology so that you hit something here, it sends a message to the cell phone network, to a server, basically does a web lookup, comes back with an answer. The minimum delay time on most of those kind of communications is 30 seconds, with typical delays being up to 2 or 3 minutes. And so that's obviously completely inappropriate for the kind of communication we're talking about. If I push a button and you have to wait 30 seconds for the slide to change, that would be pretty stupid. It also seems really inappropriate to try to communicate from here to here by going up to the cell phone network, calling off to Palm in California, sending back message to my local server, and so on. So that technology really doesn't seem very appropriate. Somebody have a question about that?
You're kind of shading a few things. So I assume that collaboration you have in mind means no remote presence. You're confining everyone to a room, and that's why you worry about these latencies in the current infrastructure. In addition, there are problems with these PANs and LANs being in the same frequency spectrum. They interfere with one another, and they will continue to do so.
That will be a very interesting research topic for the investigate next year when there are a lot more of them.
And also the IRDA stuff is directional for a recent technological decision was made that Palm devices were to talk to one another directly. They can beam spread at some satellites of range.
Right, so it is possible to have IR that's less directional.
Less directional and lower bandwidth. So these things are short range right now because of high bandwidth.
Well, it's also for power reasons, of course.
It's also power reasons. But you can, for example, control a television with a Palm Pilot if you're clever about it with a wide range.
Right. Well, and so I mean, these are just some technologies that are available today. I mean, every time I give this talk, somebody says, "Well, I have technology that you might imagine using." And that's certainly true. I'm mainly interested in ones you can buy off the shelf or that might be widely available. And I've tried to find wireless solutions that we can use today. And it's basically there is nothing wireless that you can use today on these devices. This is the best I can find for, there's 2 or 3 competitors, wireless technologies you can use today if you have a PCMCIA slot.
But do you have a bandwidth in mind, Brad?
Sure, we do. We have all sorts of requirements for different things. In this particular application, you see pictures are showing up here, so that needs higher bandwidth. In other situations, we just need a few bytes a second, so it's really not.
And latencies are typically less than a second?
Well, for this, yeah. So when I go to the next slide, you'll see that when I go to the next slide, you'll see that it pops up there and it pops up here pretty much at the same time. So, we did that. And then when I want wires, we've been using this board, this little PCMCIA card that plugs into a laptop so I can get multiple serial ports out of a laptop. But of course, it's easy to get boards for PCs if you've got the serial ports. But that's really a short-term solution.
What's the part of multiple serial inputs to the same PC?
Well, so I can run all these different devices off the same computer, and I'll be showing you some applications of that in a minute. So the first application we did was called Remote Commander, and now I'm going to switch to another device so I can show that. See the problem why here. The idea of this motivation was that I'm always in these design meetings with various people, and somebody's at the computer showing off an application or showing off a design or whatever, and everybody in the room wants to have their turn at it. So they want to be able to have their turn of talking about it, or you might have a bunch of pebbles on the screen or some other thing, and somebody says, go point on that button. And so of course I come up here and try and point, oh no, not that one, the one slightly to the left, whatever. And so instead of requiring everybody to try and tell you what to do, the idea of the Remote Commander program is that everybody in the room gets to control the cursor from their own handheld. Okay? And if we have a volunteer, we can actually show that in working. Okay, so this one is controlling it, and this one as well. I want to try.
So you can address contention?
That's a question that I'll be addressing in a minute.
Moving cursors.
Right. So if I try and do something, and if you move around, it's touching the screen. Okay, so that you can move the cursor as well. And if you want to draw something, you have to use this button, the top button, typically with your thumb, your other hand, and that will press the mouse button. So it's like using a laptop where you have a button that's separate from the touchpad area.
Can you tell us what she sees on that, or
it's just a blank screen? We'll get that. And so the current version has no floor control. So we're doing a study right now for the Extreme Massachusetts on this issue of floor control.
What's that term mean?
Floor control. Floor control is the idea of who has the floor. It's from Robert's Rules of Order, kind of meetings. And the basic idea is that there's one cursor, and we're trying to share it, just like there's one person allowed to talk at a time in the formal meeting. Who gets the turn? Whose turn is it? And there are lots of different ways that people have looked at for doing that. The most obvious one is moderator, where I get to decide who has the floor. So I would say you're not allowed to do that anymore. Other one is the one that's currently implemented, which is free for all, where it's all kind of mixed together. But people have other ideas of other floor control mechanisms that might be appropriate for different kinds of meetings, different kinds of activities, different kinds of applications. And so we're doing a study right now, which we hope to have preliminary results from before the CHI short paper deadline, that is going to look at this issue in the context of a group of people composites. So that should be kind of fun. You did that. But that's okay, I don't want to. So what we're seeing on the slide is the blank screen, and basically the whole area is a touchpad, and it works pretty much like a laptop. There's also a button on the screen, or you can use the top button to press, and as I said, on the palm-size CE devices, there's a rocker switch on the side, and we use that as the action button, as the mouse button. And also there's another button here that we use for the right button. So there's the right button as well.
Is this shared cursor control dependent upon your multiple serial port card? The cables are
No, it works with this one too.
Okay.
So we have, I'm going to talk about the architecture later, but we have an architecture that allows all these devices to come in at the same time. We need a way for the communication to work, and so the easiest way to start was with serial ports. But we also support sockets and lots of other things. We can also do keyboard so that if you know graffiti or jot on this, or actually the character recognition or keyboard on these kind of devices works as well, then everybody's keyboard input can be input. And then we designed our own little pop-up keyboard so that everybody could get to the weird keys like function keys and that kind of stuff. Yeah, that's how you get the keyboard. And then the application I'm actually using that you're seeing here is actually a special application that's not the remote commander, that we call the Slideshow Commander, kind of based on the remote commander idea. But instead of just having a blank screen, we're using the fact that there is a screen on these devices, and then we can display things there. And so we connect to PowerPoint 97 and to PowerPoint 2000 and ask it to give us some information back. And so what we get, first of all, we get the ability to change slides, which is pretty easy. We can either use space to go forwards and backspace to go backwards, and those are very simple graffiti gestures. I also have the hard buttons on this device wired to do the same thing, and we built a really big button on this device so I could touch it with my finger. On one screen you can see a picture of the slide, and the advantage of that is you can scribble on it. And I can write things fairly well on this size device. On the little devices, it's much harder to write anything legible. I guess I should erase this first. I don't have particularly good handwriting. But you can write on these devices, and you get to see in your hand what the slide looks like. Another pane shows the notes of the current slide. So if you're the kind of person that makes notes to help you go through the slide, or slides are all pictures or whatever, then you can have your notes right in your hand, so you don't have to print them out and have paper versions. Of course, I have a list of titles so that I can jump around, and it shows you the current slide. So we're right here on the Slideshow Commander slide, and if I wanted to go back to the beginning of the talk, I could just tap on it. It would go there, and I probably can go back to where it was.
This is an interface to PowerPoint on the Clio, on the tablet?
Correct.
Is that what I'm seeing?
And we have it for the Palm and the other Windows CE devices as well. And then the third pane we have just on the Palm device, we haven't around to implementing it on other devices, is a timer pane so that I can see how long my talk is left and that kind of thing. So that's kind of useful, although it's not right here, so I need it for this talk. And this is a very popular application. A lot of people downloaded it. There's been talk of commercializing it, and it seems like it's ready for people to use right now. We have lots of ideas of things to do further with it. So Windows CE. So over the summer, two HCI master students, I don't see them here, did a study with me of contextual inquiry of 9 presentations from videotapes. Some of them were the HCI seminar series, some were net meeting kind of talks. So some people remote, some people local. Some of the talks were, the very formal presentations, some were less formal. And most of them use PowerPoints, but not all of them. And they found in the terminology of contextual inquiry lots of breakdowns or lots of little problems. They classified them into different kinds and rated how much time was lost to these. And in a typical talk, about 9 minutes out of 60 minutes, or about 15% of the talk was wasted to these little breakdowns. What were they? There were things like the speaker wanted to be like I am wandering around, but every time they wanted to change slides, they'd walk back over to the PC and push the button. Or they wanted to go backwards and they thought that they could use the right button, and that popped up this obnoxious menu, and then they tried to use that, and that didn't work out well. So they lots of little problems. people would lose track of times and they'd ask somebody in the audience how long they had. Another thing is that they would speak a URL or some other piece of information that the audience would then have to try and copy down, and they'd spend a lot of time reiterating that. We've identified lots of little problems like this, and then we tried to fix up our slideshow program to alleviate the ones that we could address easily. And what happened was that we then did another study that showed that, sure enough, those problems didn't exist, and some new problems came up, which we're now working on. And we're looking at some of the other techniques that were found to be problematic, like in a lot of these meetings or talks, there were a lot of demos, so we want to figure out how we can use this to make it much more seamless to switch back and forth to demos. There's often a lot of technology like projectors and lights and sound systems, and again, this could be used as a kind of remote control for those devices, so we might be able to make it much smoother to handle lots of the other problems as well. We're looking at other advances or changes, additions to this device. In particular, some of the faculty have said that they used to use blackboards in the old days. Then they switched to overheads, and in both of those cases they could still handwrite fairly well. But now they switched to PowerPoint, and they really miss the opportunity to be able to write as part of their presentation. And if anybody's ever tried to write with a mouse, you know that that's pretty much impossible. So that maybe this is as a way of getting back to the situation where you can handwrite on the slide. So, you might write code stuff. I'm stuck back in the Pascal days. Or you could, write equations, whatever. Or you can write, talk to the chemistry professors, and they want to, go back to being able to write on their slides. Things like that. So these are some of the kind of, I should have picked this part here. Color was absolutely picked. Boy, that really doesn't show up very well. Looks fine over there. So that you get this kind of ability back in PowerPoint that has pretty much been lost. And so our future directions include what to do with the scribbles once you've written them there. We want to put them into the slide so you can print them out or save them for later. If the students have this on their handhelds and they want to take their private notes on top of the talk, what should be done with those? How we make the drawing easier. It's still a little bit awkward, especially on the little devices. And so there's a lot of interesting user interface and practical issues to be looked at.
The annotations are all going to be written visual as opposed to speech, for example.
The intention is to enhance lectures. Certainly we could connect in with the kind of stuff that Greg About talked about a few weeks ago, where the whole talk is recorded. This one's being recorded. Synchronizing the notes with that kind of technology is what they're working on, so we could certainly imagine connecting with that.
That device even has a microphone on it, doesn't it?
It's terrible. You really don't want to use this microphone. But that's, conceptually possible. It also doesn't have enough memory to record the whole talk. Okay, another application we developed, PowerPoint and the Slideshow Commander and the Remote Commander we saw all work with the real cursor that's built into the programs. And the advantage of that, of course, is it works with any program. It works with Word or Illustrator or PowerPoint or anything. So that if you have a bunch of people in the room collaborating about one particular application, then you can just use that, any of those, you can use applications so everybody can input. With the Scribble program, everybody gets their own cursor. So if we'll go back to that. So let me exit out of here, actually. We'll just go to the desktop. I'll use this one. And bring up Scribble here. The idea is that we can scribble, this is me, and that's you that have, it uses the name of the terminal. Oh, and also came up. Just slide it in. Okay, so that's you. And we can make it better color. I guess why it's not whatever. And then, again, if you hold this down, then you can scribble. And you can scribble anywhere on the screen. It's as if there's a thin, layer, on top of the screen, a transparent window or whatever. And then we can both write at the same time. But of course, we can't do anything to the real application, because the real application cursor is still somewhere else. Oh, wrong mouse. Yeah. So that's the real cursor, and the R cursor. And the idea is that this is just an ephemeral drawing. It's really easy to erase by just hitting the refresh button. It erases it from the screen. And lets a bunch of people point, is basically the intention. And everybody has their own cursor of different shapes and different colors. Okay. Now, so that's two cases. One where everybody controls the one real cursor. Another one where everybody has their own cursor but can't affect the application. The third case is where you're willing to build a custom application that knows about multiple cursors. And then we have a protocol that lets you, everybody have their own cursor within that kind of application. So one might imagine in some future day that every application, is multi-user aware, but that's certainly not here yet. But we can build custom applications that know about multiple cursors. And the first one we did is called Pebbles Draw. And the idea of that is that it's a shared whiteboard application where everybody in the room can draw independently at the same time with their own cursor. And this is called single display groupware. Okay, most groupware assumes everybody has their own display in their separate office or their separate room, and they have their display and their input devices, and there's communication amongst the devices, and that's what the software does. In this kind of software, there's one display, and everybody's trying to share it. And there's a lot of interesting new issues come up with that. For example, people want to edit at the same time, and if you use top-down menus, then that's going to obscure where I'm trying to work. The palettes typically show what mode you're in by darkening out the current mode, right? So it'll just fill this in. That'll tell you that you're trying to draw circles now. But that doesn't make any sense if you have multiple people sharing that one palette, right? Also, the selection handles. How do you deal with selection handles for multiple people? So there are lots of interesting user interface issues, and so this tool that we've built is designed to try to investigate those. Also, the issue of undo, which does come up in multi-user applications, having single undo and multiple undo. So we built this tool, and I can demonstrate it working. Stop the show. And I wanted to be, I'm going to use the Remote Commander program to try and find the right program, because then I can click on it. Right? So now I'm using this in Remote Commander mode where I can control the real cursor. And now if I switch to the multi-cursor application, then I'm one of these cursors in here instead of the real cursor. and you are teaching switch the cursor, and then you're this one. Now, of course, if you take the cursor out of the window, it disappears because it's not the real cursor. But within the window, it operates just like a regular cursor. And furthermore, we're totally independent. So if I select something and move it around, then that's my selection. And if she were to go over and hit copy or cut or something, it would not affect my object because I have it selected. And there are lots of issues. Everybody always asks, well, you know, if I draw something, is it then mine forever? No, it's just yours as long as you have it selected. As soon as I unselect it, then it's up for grabs again. What happens if we both try and delete things at the same time? Well, it's instrumented to try and make sure that that doesn't crash the system. If I delete something, what do you do?
Is it voice activated?
Scroll down.
Scroll down.
I thought it was voice activated by when you said crash the system.
Yeah. The widgets like the scroll bars and everything can be operated by these remote cursors, including the pop-up menus. So that was a trick. And I can even actually go between windows. So we have this undo dialog box that shows what operations are done by each person. So if I move something, then it shows the squiggle that was done by me. And if she was to do something, you're in it. Then it would show her with the star, which is her cursor. And just to show one thing, when she selects things, she gets stars around them, right? And if she has nothing selected, very good. You can see it better. If she goes to the menu now and tries to do a cut, then it's all grayed out because she doesn't have anything selected. But if I go to the menu, then of course I can do a cut because I have something selected. And then in terms of undo, then if we do undo by user, if I do that, then of course the object will come back. If she were to hit undo by user, then it would go and undo whatever lesson she did, which I forget what that was. You can hop up from the menu, and you can see what it was that she just did. And then there's global undo, which goes through the history in order of all the objects that we have. So this, we use this to explore a lot of these different issues, came up with some interesting solutions. Haven't really investigated this much further in the past year.
There's nothing, it's a blind palette that you're working from on the...
And again, it's a blank screen. So one of the interesting issues is maybe we should move some of these controls into the handheld. And maybe that would be better, maybe not. So there are lots of interesting issues that could be explored further in this direction. Let's go back to Tom. Interesting that didn't read the charts. Okay, so another application we have is chat, which lets you communicate amongst the different devices in the room. So, if you want to send a side message to each other, a lot of people think that's a really bad idea. But there are certain kinds of meetings where it's actually absolutely critical, like negotiation meetings. If you've ever been in one, it's kind of interesting. The lawyers always send notes back to each other and sticking to the side of the table to make sure the other people can't see them. So in these meetings, sending side messages is very critical. And there's actually some evidence, and if anybody has a reference for this, I appreciate it. I only heard anecdotally that side conversations are actually a crucial part of other meetings in terms of being productive and making progress. And this will let you send to everybody or only to a particular user. All right, now we're going to switch gears from groups and talk a little bit about using these devices for individuals. And I remind you again of the picture down here where we're talking about how to make it so that everybody can use these while they're recharging next to their computer. And the basic idea is that we can use this as a customizable input device. It's a nice touch-sensitive screen. It has reasonable size for some of these things. Maybe we can extend the desktop applications. So the first thing I did, which is based on some work I did back 15 years ago when I was a PhD student, was the idea of scrolling. And so the basic idea is that you can use your left hand to scroll while you're using the right hand on the mouse. So if you're thinking about browsing web pages, you scroll down and you click on a link, and you scroll down and click on a link. Kind of tedious to go back and forth to the scroll bars. Maybe we could use the left hand to do this, to do the scrolling for you. And in fact, the studies that we did back 15 years ago showed that in fact scrolling could be done faster with the left hand. And there's been other studies done by IBM and other people that have confirmed this. There's a small effect that you can go a little faster with the other hand. So we built 3 different scroller devices on the Palm screen that you can use with your left hand. I'll have to show you that. Another thing we built is a little task switcher. The idea of this is that in Windows, with the MDI interface, multi-document interface, that was much more prevalent before Windows, PowerPoint 2000 or Word 2000. There was this Windows menu for applications where you switched among the different windows inside one application, and then there was a taskbar where you switched amongst the different applications. So we combined those into one control, and you put it in your left hand, and then you can easily switch applications without having to move the mouse back and forth to different places. Another application that we wrote a little paper about is the remote clipboard, and the idea of this is that the main way that these things are set up for transferring information is hot sync. The CE calls it active sync, where you transfer everything on one device to the other device. And it takes about a minute, and it's only something you do every now and then. It's really awkward if you want to transfer, one phone number or one email address or whatever. So we were trying to think of a way to make it more convenient, and the most obvious way of transferring information in most applications is cut and paste. And so the idea of the remote clipboard is that the clipboard of this device is connected to the clipboard of your PC. So all the devices you're sitting in front of have one clipboard, in effect. And anytime you cut on one, you can then, turn to the other one and do a paste, and that will work out. And we have a little, Rob Miller is a main author on this, has a little paper that talks about, the implementation issues and the security issues and a few other things about making this work really easily. It's a very nice little way of, making it very fluid to use multiple devices, which is now pretty obvious. We extended that into something we call the Web Assistant, and the idea of this was to support the kind of browsing of the World Wide Web that sometimes is called hub and spoke. You have a central page, maybe it's a search result page or the index page, the table of contents page. You click on a link, you go off, find, investigate that for a while, then you go back to the main page, click on the next link, go off, and come back. And so you keep going off and coming back to the same page as a way of getting the next link. What the Web Assistant does is it lets you copy all the links from the region of the page into your handheld and then go through them one at a time. It's important to note that this, unlike regular web pages, is only reloaded on demand, right? Because the idea is to keep your hub page while you're going off from the other one. So instead of going back, you can just click on the next link automatically. One reason we require you to select a region and copy it of the page that you want to copy the links out of. We looked at a lot of search results pages, and often more than half, sometimes 90% of the links on the page are actually ads and nothing related to your actual search results. So we're working on Rob's PhD thesis is actually technology that will help with automatically pulling out the relevant parts of the page to download. But for the time being, we just let you do it manually. And then the ultimate tool, I guess, for individual use is something I call the shortcutter. And the idea of this is that you can build arbitrary panels of controls. So that there's a little direct manipulation editor on the Palm Pilot. This one only works in the Palm currently. We're hoping to port it pretty soon. There's a direct manipulation editor where you build little panels, and then you assign actions to each of the things. You can have knobs like this, or you can have buttons or scroll bars. Pretty much all the widgets. There's mouse control pads, things like that. You build these panels up. You say what each button or each widget does, and then it communicates to your existing PC applications. You can build control panels that way. Why would this be useful? Well, we thought of a bunch of scenarios of things that this might be useful for, and we're always interested in more reasons why this might be compelling. A number pad if you don't have one on your laptop. Again, scrolling, we've done. People use Winamp, the music player for PCs. So we built a little control panel to control that remotely. In fact, actually, a commercial company has built a product around the Pebbles architecture to do that, so that they have a little product where you can control your Winamp player from the Palm. People want to do it from across the room. Also, Winamp has this thing where it'll draw, pictures on the screen to animate, in time to the music, and that would be messed up by, making it louder and softer and that kind of thing. So, again, we can do all that from the little panel. You can send any keyboard key, mouse button, scrolling action, a string. You can open a file or URL. You can run an application. We made a hack so that you can, anything that you can do from a PC menu button, menu or toolbar, we can do even if it doesn't have an accelerator key. And you, of course, can switch to different shortcutter panels. And we've made it so that the shortcutter panels are little libraries so that you can easily share them and put them on the web, and we supply a few of them. Macros, we haven't quite finished yet, but basically you will be able to make a series of actions at one time. And then another idea is application-specific. Basically, we've discovered that a lot of times we have the same command we want to give that in different applications has different accelerators. So if you Netscape and Internet Explorer have different keyboard shortcuts for next and previous, and neither of them is customizable. We use 4 or 5 different compilers as part of this project, and they a bunch of them have different keyboard keys for compile and that kind of thing. So rather than trying to remember which one we're in now, or going up to the menu and doing the obnoxious thing, we just built a control panel that asks the PC which application is running and sends the appropriate key depending on what application is in front. This summer, we did a study of two-handed use of the PC, and I'm happy to say it was accepted for Chi 2000, and we'll be going to present that. It was 2 more Masters of ACI students that did this with me. The idea is that we have the same setup again. How can we use the left hand effectively? We did a bunch of studies. The first one was a look at how fast could you control buttons, what kind of errors people made, what kind of speed, whether they looked at them. So we had different configurations of buttons with nothing on them. And the stimulus was that on the PC screen we showed them a picture of what button they're supposed to push, and then they're supposed to push it with their left finger on the Palm screen. And we measured the accuracy and the speed, and we used video to check and see whether they were looking at the Palm before they did it, and we got some nice results. As expected, the time depends on how small the buttons are, so the smaller, the more accurate people had to be, the longer it took. The error rates, of course, were very low, but they did go up as we added more buttons. And for a few buttons, for up to about 6 buttons, people were essentially equally accurate, and they didn't need to look at the Palm Pilot screen. So we can basically, we feel we can pretty easily put up to 6 to 8 buttons on the Palm screen and have people be able to touch them by feel. And how do they do that? Well, you know, when you acquire this device, you've got the edges of the screen to hold, and you can kind of tell where your finger is with a certain accuracy by just by the edges. Well,
Do you have any sense of, standard remote controls have physical buttons, and you get physical feedback from those things, and also people get very good at operating those in the dark. Do you have a sense of the comparative error rates for a system that gives you physical feedback versus these systems that give you...
Yeah, that would be interesting, but no, I don't. Does anybody know of any studies, got a lot of basic talent in the room, of hitting buttons on physical devices without looking?
I've got a sense that that's why the software renditions of remote controls, similar to Pilot, Meridian, and a bunch of companies Microsoft are selling, they haven't sold very well to replace the remote controls.
It's possible. Okay, so that was the first study. The second study was something that we were interested in, but we couldn't find any data on at all, which is how long does it take to move both hands to these devices? So if you go to the old, Cardinal Newell textbook, it tells you how long it takes to move one hand to the keyboard and back, although our numbers are entirely different than theirs, and it would be interesting if anybody could help us understand why that is. But we couldn't find any information about how long it takes to move 2 hands from the keyboard to devices. And so we wanted to see if there was a big penalty for moving both hands to the devices. So conceivably people could move both hands separately, and so it would take twice as long. But we didn't think that was going to be the case. And the students who did this did a really clever job of coming up with words that required you to use both hands, right? So Apple starts with your left hand, Peach starts with your right hand, and they kind of alternate keys. They also end with letters done with the opposite hands. And so by averaging across all these words, we get a really good sense of how long it takes to move and then start typing, and move and start typing. So there were 3 conditions, basically. One where you had to click into the next cell, so that was moving one hand. Another one where you just had to hit a big old tab key on the Palm Pilot, so that was just moving the other hand. And the third one was where you had to kind of shift click, which required you to move both hands. And so the results were very interesting. The main results that we were looking for is that the time to move both hands was about 15% slower than to move one hand. Okay, so another way of saying it is there's very little penalty for moving both hands to both devices than to move just one hand to the mouse. Okay, in a little more detail, we explained the lower time for the longer time for the keyboard to the PDA because people weren't as familiar with that device, so it took longer to acquire it. But going back, if you think about a PC keyboard, there's 2 banks of function keys of number pad and the other function keys. So the distance to the mouse is actually quite a bit long from the mouse to the keyboard, quite a bit longer than on the other side. So that's how we explain the shorter time going back. Oops, I circled it and then these times were what we were mainly interested in. So, yeah.
You measure the error rates because I think when they get back to the keyboard, it's often that they are one key off, and with 2 hands, that should happen more often even than with one hand.
I don't think we looked at that. I don't know. We probably have the data.
But I use the mouse sometimes. I'm simply misplace my hand by one key, but with 2 hands, you don't even have the reference of the other hand, so that should go up.
Yeah, that's interesting. Interesting to look at. We'll have to go back to see if we got that data. Mary?
It seems to be the premise of this experiment keyboard touch typing. The fraction of the users actually touch typing.
Yeah, we do have that information, and it didn't. There was no statistical correlation between their typing speed and any of these results. And it's also,
But were they actually positioning them on home keys and then typing the letters, or were they just going and typing the
we probably have that information, and I would imagine that it would correlate with, whether they position their hands correctly would correlate with their typing speed, on the typing test. And that didn't have that information. But whether they were just looking for one key, they knew they had to type a whole word. And whether they would say, well, I'm going to quickly type the key, and then I'll worry about getting my hands in the right place so I can type the rest of the letters. We certainly didn't see anybody gaming the system that way. So I think it's a valid measurement of how fast they got ready to type. Okay, the third test was again to see if we could get any impact on an application, not just these artificial tasks, but actually doing something people would want to do. And we were luckily able to get the actual study that a colleague did in IBM. He sent us all his material. We were able to reproduce his study exactly. And the task is that you've got this really long page. You can tell by the size of the marker here that it's actually quite a long page. Somewhere in the page is this link, and the task is to scroll, find the link, and click on it. Okay, so and there are various different kinds of scrollers that we used that you saw before. The different kinds we designed for the Palm, as well as the regular scroll bars on the mouse using the mouse, and we also tested the scroll wheel, on the Microsoft mouse. And the results were very encouraging. The winner was our button panel scroller with auto repeat of the button. So when you pressed on the button, it would auto repeat up or down. That's the shortest part here. The next one is using the mouse on the real scroll bars. Then the two other scroll bars that we designed. Finally, the using the roller, which, interesting enough, nobody used the rolling feature. Everybody used the rate control mechanism of it. If you're familiar with those, you press on the ball and hold it down, then the text scrolls in proportion to how far you move from the original position. Anybody who has a scroller ball on their, a roll ball on their mouse? Do you guys use it for scrolling? No, most people don't. You do? No, it's not very commonly used. Do you use this rate or the rolling it?
Both depends on the size of the page.
Mm-hmm. How far you have to go. So the one that was the worst, which is actually my favorite scrolling mechanism, was the rate-controlled joystick on the Palm. And I expected, since to match the performance of the, using the scroll ball, because it's basically the same mechanism. But the results of this are the same as all of Ted Selker's papers about the scroll stick, which is the actual parameters, the engineering of these devices is really key to making them usable. That, in fact, our scrolling was too fast, so that people would miss the target they were trying to get to. So that there's a lot of engineering that has to go into these devices to try and make them really usable. And this is actually the second time we tried it. The first time was even worse. So I tried to re-engineer the scroll bar to make the scrolling rate to make it better, and didn't succeed at that. There's certainly a lot of engineering that we need to go into these kind of devices to make them optimal.
Have you also tested Scribble for scrolling? I know that
We didn't have that condition in this experiment, but that would be a good thing to add. Do you do that with your left hand or with your right hand?
depends how far from the keyboard.
Yeah, one of our experimenters said that actually her normal mode of scrolling and clicking is to actually cross her left hand over to hit the arrow keys, which are on the right side, while leaving her right hand on the mouse, so that she can, in fact, use the keyboard method. So we probably should have tested that one as well, but it wasn't this experiment.
Could you just clarify, this is the time to scroll 10 pages and then click on the next button?
No, each page had you had to scroll. Each page had a next button in it. So to get to the second page, you had to click the next button on the first page. Right. So it was scroll, click, that gets you the second page. Scroll, click.
And the next wasn't always the last thing on the screen.
It was somewhere in this, each page was actually about 10 screenfuls vertically. So somewhere in those 10 screenfuls was the next button. So you had to scroll down till you could find it, and then click on it. That would get you the second page, and then you went 10 pages. We saw, learning effects, lots of other results from this experiment.
Did you try different rates for the auto repeat on the button?
For these buttons? No. We just, tune them to what would seem like the best rate.
So there wasn't any sort of like user testing to determine the optimal rate.
Correct. Also, it's also limited by the speed that these devices will accept. These programs will accept auto repeat. If you go too fast, then it swims after you release, and it swims while it's waiting to try and catch up with all the users. So one of the problems is that you have to be careful about is giving these since we're dealing with desktop applications, you can't give them input fast so they can process it, or else they get way behind. Here's the architecture that we're using. We're running a lot of different applications on these devices, as maybe you've noticed, and we're also running lots of different devices at once. So we have this central program we call Pebbles PC, which is basically a dispatcher that takes the input from all of the different devices, all the different applications on the devices, and then dispatches them to various different handlers. Okay? And so we have different handlers for the different activities. And the idea is that if you have a new idea for an activity, a new thing that you'd like to use this architecture for, then typically you have to write a new POM side or PDA side for it, and a new handler on the other side. And then they'll talk together through our architecture. And we have libraries and things to make that a lot easier to do. And then often these little plugins, that we call them, want to do something. So what remote command does is actually takes the inputs from the POM or the Windows CE machine and puts them into the Windows event queue. So your Word or PowerPoint or whatever thinks that it's just getting regular keyboard and mouse events, but they're actually artificially generated by our program. The other programs do various things. For Slideshow, we actually built an OLE component that connects into the OLE interface that PowerPoint provides, and that lets us get the information out of PowerPoint. Right? We don't just want to give commands to it, we want to get the current slide, the picture, the notes, and things like that. And so this OLE component we built actually requests from PowerPoint this information. The multi-cursor obviously has to have a lot of communication with the application to give it the custom cursor events. And we have interfaces that use either the Windows event stream or sockets. So it's pretty easy to connect various applications into this architecture. As I was mentioning, there's a commercial product that uses this architecture. There's a number of research groups around who are interested in using this for various kinds of activities that all revolve around using handheld devices and PCs, multiple handheld devices at the same time. So if you have any applications that you think this might be useful for, then we'd be very interested in talking about how that might fit in. How do you say that? So we have this is happily an ongoing project. We have a lot of ideas for things to do in the future, a lot of activity going on. One of the, Microsoft has funded us to look particularly at using Windows CE devices, probably more like this kind, in a classroom. So everybody in a classroom would have these devices. If you saw Greg About's talk, he talked about note-taking. So maybe these devices would help with note-taking. We also have lots of other ideas of activities that these kind of devices might help support. They might help with tests, pop quizzes, surveys, instant grading of homeworks. A number of faculty are very excited by the ability to give a quick test of their students and immediately get feedback on what people know, and then they'll know what to go on or to talk about that topic. A related idea is something called concept tests, and this is actually being used by a number of faculty. For example, chemistry, that's using the first year chemistry courses here apparently. The idea is that every 10 minutes or so through a lecture, and these are enormous lectures, the professor will stop and ask a question, multiple choice question. Students answer the question, then they talk among themselves about the question, and then they answer it again. And currently they have no technological support for this, they just kind of raise their hands, which kind of defeats some of the advantage of this thing, because you're supposed to answer anonymously and then discuss it. And these have been studied extensively. There's a lot of demonstration that this actually makes learning much better. They go through the material actually faster because the professor knows what people understand and can just plow ahead if people understand it, talk only about what things people don't understand. There's a commercial product I found on the net that talks about enforcing or encouraging full class participation, and it has backed up by studies that show when you make everybody in the class answer a question, then everybody learns better, especially the people who are lower performing, who would tend to be the ones who wouldn't answer. So this kind of technology can force everybody to answer, and the faculty, the instructor can say, oh, well, Joe, you didn't answer this question, make up your own, and basically get a printout of who didn't answer, who's getting it correct, and all this can be done instantly if it's a multiple choice question, especially. So that's kind of an interesting application. Another thing that we're looking at is meetings where there's public information which is on a big display, like maybe there's a map or a graph or a chart, and people have their own private interests, their own private information that they want to, what the military calls drill down on. Okay, so I see there's a map with a bunch of units on it, and I'm particularly interested in this unit, but I don't want to bother the whole meeting with, with the details. So I don't want it to appear on the big display. So we're working on techniques to have what we call private drill down of public information, where you get the details in your handheld for stuff that you point to on the big computer. Also, there's the inverse where you have your own personal information you want to add to the display. Then that just works the same way in the reverse direction. There's the idea of, we talked about the remote control of devices. So you have your handheld with infrared, you can point it at something and control it. I think there's a real opportunity for controlling much smarter devices. The problem with universal controllers today is you are responsible as a user or in the factory for programming it to know how to talk to each device you want to. But IR, for example, is a two-way communication protocol. You could have the device tell you what it can do. And so we have this idea for a universal controller where you point it at the device and the device says, well, here's the kind of stuff I can talk about. And then your handheld configures a control panel appropriate to the kind of display it has. And you see that there's enormously different form factors for displays. So it's not like the projector is going to know how to display on every possible configuration, color, black and white, big and little. Also might take into account user preferences. So whenever I walk up to a copier, I want it to do letter, no matter what the last person set it up to be. Might as well default to stapled sort. And so I can program up my personal universal controller for copiers so I know where the buttons are and it does the things I want, and I just point to the copier and just push the button I'm used to. Then you could have your personalized control panel for lots of devices. This is similar to a lot of things other people are looking at. There's something from Microsoft called Universal Plug and Play. It's related a bit to the Java Genie work. And there's a commercial consortium called Salutation that's also looking at relating. So there are a lot of people kind of working in this domain, but nobody doing this, what I was talking about. A lot of other things we're thinking of, we're not necessarily going to do, but which we've listed in proposals or whatever. Taking attendance, voting. If you have a Robert's Rules of Order kind of meeting and you want to take a vote, obviously it makes sense to do it this way. Coordinating schedules and to-do lists. So at the end of the meeting, we have to-do lists, and Joe's going to do this and Bob's going to do that. And it might as well just distribute it and put it in your to-do list automatically, or schedule meetings, that kind of stuff. There's, again, a lot of CSCW literature I think we can take advantage of that has shown advantages for certain kinds of computerized support for meetings. So there's something called decision support software, decision, it's an extra letter on it, that has demonstrated significant gains for brainstorming and some other parts of meetings. Maybe we can do those with little computers, handheld computers, instead of requiring you to go into a special room with lots of built-in hardware or a lot of infrastructure. Because basically these techniques don't get used because they're such a pain to set up. Maybe if you could just pull something out of your pocket and you want to brainstorm for 5 minutes, you could just use this technology and you wouldn't have to, wouldn't be such a big deal. And then you could use this technology more often when it was appropriate. So as I mentioned, most of the software is available for free, and our website is easy to find from my website, or basically just Pebbles. We released the first version about 1.5 years ago, and it's been downloaded about 15,000 times, so it's pretty popular. We've gotten a little bit of feedback. I'm pressing the button. And we're negotiating, when the tech transfer office gets into it, it's always a pain, but we're negotiating about commercialization of this, of some of these applications. So maybe I'll have a pretty box to show next time I do this talk. So I think you can count on PDAs, or whatever you want to call them, handheld computers, becoming more and more ubiquitous. It's going to be the case that there's going to be really easy communication, not just hot syncing, but radio communication of some form or another. So it really behooves us to be looking at new things that's going to be useful for. So the typical Bluetooth scenario is your Palm Pilot has your telephone number on it, and it talks to your cell phone and tells it the telephone number. But I think a lot of the things that we're looking at are much more exciting applications for a lot of this communication, for a lot more compelling uses for handhelds in more kinds of situations than just to keep your calendar and your to-do list. And I think our project is off to a pretty good start with looking at how these things might work. This research is funded by DARPA and Microsoft. We've got equipment grants from Palm and IBM. Actually, I have a big box of Palm 3s. Some of you have borrowed some of them for the class. I lent them to, I guess it was Ken, to use in the class. So I still have more, so if you're interested in trying out some of the software or participating in this research, or have another really good excuse for why you need a Palm, I have some more. I'll lend you. And we're always looking for new partners. We put an application to Hewlett-Packard for like 200 of these to try this out in classrooms. So I think we're going to get a lot of interesting progress on this. Okay, thank you. Questions?
You seem to be mainly working with Windows, different versions, and Palm OS. Will you also do research with Linux?
The PC side, we support a whole bunch of different operating systems on the handheld. So Palm OS and Windows CE are entirely different. On the PC side, we only supporting Windows now. Because even in Linux, as far as I know, nobody much uses Linux for PowerPoint, for doing presentations. So there's been incredibly little request. There's certainly nothing in our architecture that makes that a bit hard. We have a Java implementation of this, so it really would be fairly easy to port this to Linux. No one's done it, no one's asked for it. If you're interested in doing it, we'll be happy to give you the sources. we've had a few requests for Macintoshes, but it's really would be fairly easy to do, but there's not much research in it.
I sort of very generously offered to treat him with Roku being home free for a brand new one to evaluate software. Clearly, this kind of work is very important to do to leverage off what's available right now, because otherwise you can do user studies. But I wanted to ask a more futuristic question, because you've had to think a lot about these limiting factors of technology and bandwidth and so forth. And you mentioned that the technologies, these are the technologies that exist, and you get questions about nanotechnology. 10, 15 years from now, say, one of the technologies that's being investigated now at MIT is, I don't know what they call it, body area network, where you actually use the conductivity of the skin to send signals around. And you communicate when you can actually send your business card with a handshake by sending signals to your skin, and power stuff in your shoes or with body.
Well, I think
the question is, 15 years from now, or whatever it is, will it be feasible to get rid of the PDAs and use our bodies to the display is external, and if I'm going to point at something, I can just use gesture.
Well, certainly, for example, in our command post, everybody wants to point to the screen using laser pointers and not using the kind of fairly awkward cursors that we have. But on the other hand, when they've tried that, it's a really bad idea to try and handwrite using a laser pointer remotely. You really need to handwrite right here. Now, whether you're going to have, magic paper, or a cross pad, or you can just write in your hand and there's a camera that's watching you, and so that's good enough. Really, that's irrelevant to our research. We're looking at the issue of distributing the computation, the display, and the input across multiple devices. And that's really not something that other people are looking at so much. So I think, this kind of scenario where you have all these computers really is very much in the line of what we're talking about, where you have this the concept that you're not just using one computer to replace another or one computer at a time, but in fact you're using multiple computing devices of different capabilities at the same time. And how does that, what's the communication protocols, what's the user interface, where do you put controls, and that kind of thing.
You're saying your research results are not specific to and will outlive the particular technologies that you're using?
We hope so. Sure.
It seems like most of what you talked about was using the PDAs as input devices for control. And a lot of applications that you hinted to at the beginning, like joint note-taking, where when you walk away, not only are your notes, but everyone else's notes are on your PDA. Have you looked at the other side of broadcasting information down? You have the Clipboard, but that was about it.
Well, no, the PowerPoint presentation, right, into your PDA appears the notes of the slide and the picture from the slide. So that's coming from the PC. And various other applications, the task switcher, So we do have applications where the PC sends stuff to the handheld. So it is a two-way communication mechanism. We haven't done any user studies of that. There are lots of interesting issues. I was talking to the networking guys, Peter Stinkus, about reliable multicast. Because, if I'm doing a lecture and I want to send everybody in the room this picture, I don't want to have to send it to each person individually. I want to send it in one packet. And we're dealing with the bandwidth of the radio, which has to be shared, so there's also some interesting issues there. There's interesting issues in test taking in terms of cheating, right? So if everybody in this room has a radio in their handheld, and I'm trying to give a test, what's to keep you from going off to Cornell or whatever, and looking at the answers, or passing notes back and forth from each other. So there's lots of interesting issues that we're seeing in the future that have to do with more of the two-way communication. We've done a few things, but not very much of it. Bob?
You have a research project that has this architecture that allows a whole bunch of neat applications and a whole bunch of neat applications. Where do you think the most important part of that, of your research is? In the broad architecture and the issues you have to solve to enable the distribution of display input processing, or in the applications themselves?
Well, the architecture really hasn't been that sophisticated. It was a nice little engineering feat, but that's really not been anything we've talked a lot about. I think the main kind of academically research issue is the one of user interface design. How do you design an interface that uses multiple devices, where some of the input can be on a handheld and some can be on the main machine, where you have different kinds of displays you're trying to use at the same time, where you have the capability of using your left hand and for on a PDA and the right hand on the mouse, using a PDA with a keyboard. What kind of displays make sense on a PDA when you've got a real display in front of you? So I think there's a lot of really interesting user interface design issues. In terms of the applications we built mainly have been to explore the space of what's useful and what sort of user interface issues come up as a result of exploring these issues.
When you have 12 people moving cursors around the screen, really all you need is a puck to really have fun. Can you do that?
Yeah, that would be fun. We haven't built that particular game. I have a high school student actually building a couple of games. We've been particularly looking for games where there's an important reason to have a big display. Right? So there's a bunch of games where you have private information. Well, a game where everything's public, you could just do on a PC without having a PDA. And a game where there's no public information, everybody could just have their PDAs talking to each other. Yeah. So we're looking for games where there's private information and public information. So the one we've done so far is Scribble. The idea is that there's this big board that everybody sees, but you have your private little cubes with their letters on it. But we'd be really interested in more games of this sort where there's private and public information and interesting issues in terms of taking turns or whatever. So the students, the 4 students who are working with me now are looking at this jigsaw puzzle, putting together a jigsaw puzzle as a group, and I think there's some interesting issues in terms of how people